Okay, guys, so today we're going to start talking about one-step equations. We're starting a journey to algebra. And this is a video. I'm only going to do the ones that I would exhibit in class. I won't be the ones that do your turn. You can find the answer key to that the day after class. All right, so the first thing we want to talk about is what are equations? So equations are math statements that tell us one expression is equal to the other. Linear equations in one variable contain only one variable. So you'll either see an x or a y or an a and only have an exponent of 1. We do not see the exponent of 1. So if you see an x, just like this, it really has an exponent of 1 that we just don't see. So we want to circle the linear equations. So looking for equations that have only one variable. This would be 1. This would not be 1. This one has too many variables. These have several terms. They are all just x, so that would make this linear because eventually we would be able to combine that up. Over here, 0 times x would cancel that out. We would really be left with 5 is equal to 28, which is not a true statement. So this is just untrue. That is not linear. There is no variable at all. 2x equals 1, just one variable. And here, x equals y, that has too many as well. All right. How do we solve linear equations? What's our goal? Our goal is to isolate, which really means get alone. How do we do this? We do this by inverse operations. Inverse is another name for opposite. Okay, so what would be the inverse of adding? The inverse of adding would be to subtract. The inverse of subtracting would be to add. The inverse of multiplying would be to divide. And the inverse of dividing would be to multiply. So let's do a few of these. I want to solve for x. I want to isolate this x, get it by itself. That means this positive 7, we're looking at the sign in front, needs to be moved to the other side. The inverse of adding is to subtract. And what you do to the left, we do to the right. Some people like to put a little wall down just to make sure you're doing the same thing to both sides. Totally up to you. The plus minus 7 will cancel, leaving us with just x. And then 10 minus 7 would get us 3. We can always check our answer by plugging the answer back in. 3 plus 7 equals 10. 10 equals 10. That is a true statement. Let's look at the next one. It doesn't have to be an x. It can be any variable. Here it's an s. Looking at this right here. So I want to isolate the s, get it by itself. We need to move this minus 4. We move it by doing the opposite. And what you do to the left, you do to the right. Here we get s is equal to -2. Over here, I want to isolate the t. Right now it's being multiplied by -5. The opposite of multiplying is to divide. I want my t to be positive, so we are going to divide by -5 because a negative divided by negative gets you positive. Again, what we do to the left, we do to the right. And we're going to show our division through a fraction like this. The -5s cancel out, getting just 1, and 1 times t is t. And on the other side, 30 divided by -5 gets us -6. Last operation here of division, the opposite of dividing is to multiply. So I'm going to multiply each side by 3. We want to use a dot for our multiplication rather than an x because it could be confused with a variable. Here the 3's would cancel out, isolating just the y, which is exactly what we want. And then 5 times 3 is 15. And again, if you wanted to check, you certainly could. 15 divided by 3 equals 5. That is a true statement. The whole goal of this is to be able to solve real-world problems. So we've got some steps. You want to understand the problem. You want to read it slowly. Think about what is unknown, what info is given, and what's being asked of you. Make a plan. Model the linear equation to match each problem. Solve, carry out your plan, and look back. Make sure your answer makes sense. All right, so let's try the first one that I have here. Lisa is cooking muffins. The recipe calls for 7 cups of sugar. She already has put in 2 cups. How many more cups does she need to put in? All right, so I'm going to let C equal cups. It helps to pick a letter that represents what you're talking about. I know the recipe calls for total. In the end, I need 7. She's already got 2 in. So how many cups plus the 2 do you need? How many more do you need to get to 7? Subtract 2 from both sides. And we get C is equal to 5. So your answer would be 5 cups. And that makes sense. 5 cups plus 2 cups gets us to a total of 7. Okay, we're at a restaurant. Mike and his 3 friends decide to divide the bill evenly. If each person paid $13, what was the total bill? So it says Mike and his 3 friends decide to divide the bill evenly. So what is the total bill? So let's leave bill as B. So the total bill is B. They're telling you the 3 friends are dividing it by 3, and then each person winds up paying $13. You'll multiply each side by 3. The opposite of dividing is to multiply. We get B is equal to 39. So your final answer would be $39. How many packages of diapers can you buy with $40 if one package costs 8? So I want to know how many packages can I buy? So it would be a multiplying 8 times, let's define a variable. Let's do P for package. So 8 times P, $8 times each package, and I have a total of $40. How many can I afford? The opposite of multiplying is to divide. What you do to the left, we do to the right. And you get P is equal to 5. So our final answer would be 5 packages. Okay. One more. After paying $5.12 for a salad, Norachi had $27.10. So this is how much he has in the end. How much money did he have before buying the salad? So let's call M for money. So money, how much he had to start with, minus the $5.12 for a salad, and he winds up with a total of $27.10. We want to know how much money did he have to begin with. So we're going to add the 512 to both sides. You may certainly use a calculator for this. So the opposite of minusing is to plus. We're left with M for money. $27.10 and $5.12 adds up to be a total of $32.22. All right, oops, sorry about that. Oh, stop. Okay, we've got one more problem to try out here. Those were your turn problems. I'm going to just do kind of an application problem here. For these problems, I will always let you know what the angles add up to be. That's not something we expect you to know at this point. So in geometry, they tell you 3 angles of a triangle always sum to be 180 degrees. So sum means to add. So I know that x plus 47 plus 58 is going to equal 180. Let's just combine these 2 guys up. And when you add those 2 together, 47 and 58, and again, a calculator is perfectly fine to use, you get 105. I need to isolate this x. Look in front of the 105, it's a plus, so we're going to do the opposite and minus. What you do to the left, you do to the right. These guys cancel out, and you get x is equal to 75. So that angle, X there, would be 75 degrees. Okay, with that, we are ending our lesson on one-step equations. Thank you very much, and I'll see you next time.